All right. Hopefully you enjoyed the big angle puzzle last night. Good times with this picture. I'm going to go ahead and walk you through finding them, although I must tell you that you could do these in different orders and use kind of different properties. So there's not just one way of doing this. The first thing I would do is pay attention to the things they tell you, like lines 1 and lines 2 are parallel. So I would definitely remind myself that those are parallel lines. And I would definitely notice that lines 3 and 4 tangents, that's important too, because we know that tangents have special properties. Theorem 10.1 tells us that we have perpendicular relationships with radii and, um, and tangent lines. And theorem 10.2 tells us that two tangents, segments from the same point outside, so that would be like these two tangents coming in, right, are going to be um, congruent. So that's really important information for us to know. Now, right off the bat, I see they didn't give me a lot of information. They gave me 48 degrees arc, and they gave me a 74-degree angle. Um, I gave you a little bonus theorem, though, that should have helped you out. This right here reminds us that if parallel lines intercept a circle, they intercept congruent arcs, right? Congruent arcs. This was the proof of that, but we don't. We just need to know the information. But what that's going to tell me is that A is 48 right off the bat. Okay, so that's helpful. Here's another huge thing that I hope you noticed. They gave us one and only one diameter. That is a very, very helpful piece of information because it divided us into two semicircles. Diameters are helpful because they divide us into two semicircles. So there's semicircle 1 and semicircle 2, right? So if B is 180, or I'm sorry, the yellow arc is 180 degrees, then B is 180 subtract 48 subtract 48. So we can get B very quickly that way. Okay. We also know that the blue arc is 180, but we'll get down to that one in a second. Now, on the top part of the circle, we still have some inscribed angles to deal with. The easiest one, and the one that I'm sure most of you guys got right away, since 48 was the only given angle, is that this inscribed angle right here, right? That inscribed angle right there had to be half of 48. Inscribed angles are half the arcs they intersect, so there's 24. But then you could also flip to G, which is inscribed with the rest, and say, well, 48 and 84 is 132, and take half of that. Um, that would also have been a way you could do that. You could have also found F first and said, hey, F is a triangle that's inscribed inside a diameter. A diameter is one of its sides. That means it has to be a right angle. That's theorem 10.9 tells us that. So you could have got a 90-degree angle there and then subtracted the triangle to get 66 either. So a lot of different ways to get 66, but we're done with the top half of the circle. So let's flip down to the bottom. You really have to start with that 74. They don't give you any other information down here. I guess I is inscribed in a semicircle also. I is a right, has to be a right angle. You could also say, well, the yellow arc is 108, is 180, half of 180 is 90, but one way or the other, that's a right angle. But really, that's about it. So let's go ahead and down to the 74, and let's use vertical angles. And then you had to use that tangent theorem 10.2 to get the congruent sides here, because otherwise you would not have been able to use this isosceles triangle, right? Base angles of an isosceles triangle are congruent. So 180 minus 74 uh, divided by 2 gives us 53 and 53. Um, and now you're almost done. Uh, because of the tangent property here, right, I know that this has to be a right angle, and I could do 90 minus 53 to get J here. I could have also got J a different way, but let's go with that for now. Theorem 10.11 says that if a tangent and a chord intersect, then the angle is half the arc. So if I double 53, I get D. D is 106. I can subtract that from 180, the blue semicircle, to get C. So that would be 74. I could have gotten J by taking half of 74, right? That's another way. Or I could have gotten C by doubling 37. That's another way of doing that. H is either half of 106, which is 53, or I could do 180 minus 90 minus 37 to get 53. So like I said, there's different ways you could have done this, different orders for certain things. Certain things you really had to start with, like down here, you better had started with that 74 or you weren't going to work your way up here. But a number of different theorems were at play. Here are all the answers together so you can kind of look at them. Take as much time as you need, and then if you still are confused about any of the relationships that we just used, please let me know. Um, we'll see some more circle puzzles maybe next week. Have a good weekend.